还是唯一上去掉的。这个是改变方向很重要的一点。好，我们看一下一个管理件。So let's have a look at what is the pulley system. 那我们先看一下这个滑轮组，它基本上有什么？它滑轮组里面，它基本上有一个滑轮，然后有一条绳子，然后跨过去，然后一端可能是固定在墙壁，然后一端就是用手拉。So let's have a view and have a watch about the pulley.
Suppose you needed to lift something, and there weren't any simple machines to help you. You'd have only your own muscles to rely on to do the work. The stronger you were, the easier it would be. If you weren't so strong, you might try to think of something to help you. A rope passed over a branch might help make the work easier. But it would also have its problems, with friction, for instance. To solve this problem, you might think of using a wheel, one with a groove in it, mounted so it can turn, and so you can hang it from something. When a rope is passed over this, it can move with much less friction than it can scraping over a branch. The groove in the wheel keeps the rope from slipping off. The whole arrangement, the wheel and the rope that goes over it, is called a pulley.
所以这里就看到定义什么滑轮，滑轮基本上是一个轮。轮里面有一个槽，方便你把绳子这个跨过去。When you wrap the cable over the groove, the pulley, okay, then it allows much easier rotation. Okay.
Pulleys are simple machines that help people do work. This one is a fixed pulley because it stays in one place as you use it. How does a fixed pulley make lifting things easier? Suppose you attach a weight or a load here. A pull down on your end of the rope causes a pull up on the other end. You apply a force in one place, and that produces a force in another place to lift the load. The amount of force you apply is the same as the force that acts on the load. If the load weighs 25 pounds, then you have to pull down with a force of 25 pounds in order to lift it. And if it weighs 50 pounds, you have to pull down with 50 pounds of force, the same amount of force you'd need to lift the load without the pulley. So a fixed pulley does not increase your force. It helps you lift things by changing the direction of force. It allows you to pull down in order to lift something up. For instance, if you want to raise a flag up a pole, you don't have to climb the pole and pull it up. You can put a fixed pulley at the top and raise the flag without leaving the ground. And if you loop the rope around a second fixed pulley at the bottom, you can also pull the flag down. If you lift something by pulling it up, only your muscles do the work. But when you pull down, your own weight can help you. Using your own weight as a force, you can raise something that weighs less than you do, but not something that weighs more. But with a pulley, you don't have to use only your own weight. Suppose you want to lift something that weighs 100 pounds. You could hang another weight, a counterweight, on your end of the rope. If the counterweight weighs weighs 90 pounds, that wouldn't lift the load. But all you'd have to supply is the difference, 10 pounds of force, and you could lift it. Fixed pulleys and counterweights are often used in lifting machines, like elevators. Counterweights sometimes make lifting easier, but there can be a big problem with them, especially if they're heavy. In order to use them, you first have to lift them to hang them in place. If you're not strong enough to do that, you still have the same problem as before, how to lift heavy things. To make that really easy, fixed pulleys aren't enough. You also need a different kind of pulley, a movable pulley. It's called that because it moves with the load. The pulley is suspended by this rope, with one portion of the rope, or rope segment, on each side. Each rope segment supports half the load. If one person supports the whole load, he supplies all the lifting force himself. But suppose two people each hold one of the rope segments. Then they share the lifting equally. They each need to lift with only half as much force. Exactly the same thing happens if one end of the rope is attached to something that doesn't move. If you're lifting the other end, you still need to lift with a force equal to only half the weight of the load. This end still supports the other half. And because the rope can roll through the pulley, when you pull up with your half, you raise the whole load. So when you apply a force here, the pulley lifts with twice as much force here. With 10 pounds of force, you can lift a load that weighs 20 pounds. Of course, now the load includes the weight of the movable pulley. With 25 pounds of force, you can lift a load that weighs 50 pounds. And with 50 pounds, you can lift a 100-pound load. But with machines, you never get something for nothing. To get this increased force, you have to move your force and increase distance. If you want to lift the load a distance of 1 foot, you have to move your force 2 feet.
Okay, so 好，所以我们等一下会上的就是我们比较关心，现在还不是力，我们比较关心的是位移。OK， 所以就比如说你这个利用动滑轮，来移动，这样你要拉末端要拉多少？ So in the case of the kinematics of pulling, we concern more about the motion. Let's say at the point of the pulling, how much the displacement you have to travel, so that you can lift up the movable pulley. So let's continue watching.
To move the load 2 feet, you move 4 feet, always twice as far. So when the movable pulley is suspended by 2 rope segments, you have to exert your force over twice the distance the load moves, and in exchange the pulley lifts with twice as much force as you do. But one big problem with movable pulleys is that you have to pull up, and for heavy loads that's not always easy. You need something that will allow you to lift by pulling down instead. But that's what a fixed pulley does. Suppose you combine the fixed pulley with the movable pulley to get the advantages of both. The movable pulley still doubles your force, and at the same time, the fixed pulley lets you pull down. So here, finally, is a simple machine that really does make lifting easier. With this arrangement of pulleys, you can lift twice your own weight. One way to compare different pulley arrangements is to use the idea of mechanical advantage. Since this pulley arrangement doubles your force, it has a mechanical advantage of 2. You can find the mechanical advantage of any pulley arrangement by simply counting the rope segments that support the movable pulley. In this case, 2. It doesn't matter where this end is attached, so for convenience you could attach it here, like this. The mechanical advantage is still the same, because the number of rope segments that support the movable pulley is is the same, 2. Why isn't the mechanical advantage 3? Aren't there 3 rope segments? You don't count this one. You only count the rope segments that directly support the movable pulley. A mechanical advantage of 2 is some help. But if you need to raise very heavy loads, you need more lifting force. You get it not by adding more muscles, but by using combinations of pulleys that give you more rope segments. Suppose you add another fixed pulley, for instance, and run the rope this way. Now 3 rope segments support the movable pulley, so the mechanical advantage is 3. Or suppose you start again with this combination, and then add another combination just like it. So you have 2 movable pulleys and 2 fixed pulleys. And then hang the load from both movable pulleys. Now, how many rope segments support the movable pulleys? 4. So that's the mechanical advantage. But why does this combination make a mechanical advantage of 4? How does this work? Let's imagine that you and 3 other people were each holding a segment of the rope. It would be clear that each person would support 1/4 of the load. If the load weighs 80 pounds, each person supports 20 pounds. But it doesn't matter what holds up the segments. So if you attach this segment here and join these 2 segments over a fixed pulley, each segment still supports 20 pounds, and you still pull with 20 pounds. But because the rope can roll through these pulleys, when you pull up with 20 pounds, that raises the whole 80-pound load. The pulley system multiplies your force by 4, so 4 is the mechanical advantage. To make things even easier, you can add another fixed pulley. So you can still apply your force to this rope, but now you can do it by pulling down with 20 pounds. The movable pulleys are still supported by the same number of rope segments. So the mechanical advantage is still the same. The pulley system still multiplies your force by 4. And in exchange, you have to exert your force 4 times the distance that the load moves. You trade distance to get force. Now, suppose you arrange these pulleys in a much more compact way. You can put these 2 pulleys next to each other on the same axle. The same with these 2. The pulleys still work the same way, and the mechanical advantage is still 4. This device is called a block. This is another block. The whole system, pulleys, blocks, and ropes, is called a block and tackle. The more pulleys and rope segments in a block and tackle, the greater the mechanical advantage, and the heavier the loads you can lift. So pulleys are simple machines that you can use in many different combinations to help you do work. But in all of them, you either change the direction of force with 1 or more fixed pulleys, or trade distance to get force, usually to lift something with a block and tackle.
Okay, so after watching this, then we're going to proceed to analyze. We already know there are a few types of pulleys. First is a fixed pulley that applies an equal force but change the direction to the opposite. And then second, there are this mover pulley. The pulley is located at somewhere between 2 ends. Okay, so one end of the cable is supported by the ceiling, the other end is supported by hand. So in this case, this mover pulley got the support from both the pull by hand and the pull by ceiling. So in this way, it can support double the weight. And then next, by combining a fixed pulley with a mover pulley, then you have a compound pulley. In this way, rather than providing an upward pulling force, now you use the fixed pulley to change the pulling direction to be downward, then it will be easier for force application to move the movable pulley. Okay, so we know that now pulley is for force transmissions, and also by having the movable pulley, you can apply mechanical advantage to increase the force applied. Okay, so now before we come to the pulley, with the two parallel line, then we're going to use the simple example to tell you if there is a pulley connecting two blocks. Okay, what will be the motion and the speed of the two blocks? 好，我们来看一个直角的这个斜坡上。OK， 你如果有两个滑块 ，OK， 这个是 A，OK， 然后这个是 B， 然后 A 跟 B 是用一条铁索啊，这个连住。Then in the middle of that, then you have a pulley. So in this case, how do you describe the motion? To define the motion of A, you can first define the coordinate of point A, XA. Or if you like, you can either use X, because I don't want X to be confused with the level direction. Then I'm going to use X for the length. And then how about the coordinate of point B? From the datum. Where do you use the datum? The datum is always referred to the fixed point. Okay? How do you define the distance there? You always define using the fixed point as a reference, and then move toward the moving point. 你看到没有？你的 A 点它是会在左边斜坡滑动 ，B 点在右边斜坡滑动，然后唯一一个可以用来做参考点的参照点的就是这个两个斜坡的这个顶峰，它上面架着一个滑轮。OK， 这滑轮是定滑轮。Okay, in this case, how long is a rod? Okay, how do you relate the positions A to position B? Okay, there is one thing that you can relate. There is a constraint. What is a constraint? The rod has a fixed length. Okay, so in this case, what is the total rod length? 这个绳索有一个全长，它是不变的。OK， 所以你可以加上 SA, which is this portion, and then next you add on this arc length. Okay, this arc length. Yeah, how do you write them? This is could be you can write them C and D. Then you have the arc length C and D. And then finally, you add this portion of the cable length. This portion of the cable length is SB. And then you sum them together, and it's equal to the total length. Okay? Okay, because the length is fixed. The total length is fixed. It's equal to SA plus SCD plus SB. And now if you are concerned about the speed, then you do time differentiation of the total length, which is equal to 0, and the distance of point A after time differentiation, then you're getting speed A, and then the LCD, because it's a pulley arc length, it doesn't change with time, then it becomes 0. And then time differentiation of the distance B with respect to time, then you give you the velocity B. Okay, so in this way, the point A to point B, okay, B is equal and opposite to A direction。所以就回到刚才我们讲的这个滑轮的一个基本功能，它不改变力，但它改变运动方向 ，OK， 或者是你施力的方向。所以你看到没有？这条线，即便是在一个斜坡上，它不是一个平行滑轮，啊，它还是一样满足这个条件。OK， so this is the very simple example to illustrate the point. So where do you find the good use of this simple fixed pulley? Okay, then let's have a view of the flying machine. 我们来看一下这个简单的这个飞行。好，同学看到没有？我们就看一下，你常吃的这个鸡胸肉 ，OK， 啊，它收缩肯定是可以把翅膀拉下来。那你不常吃的这个胸上肌 ，OK， 或者肌肉一点点的，它怎么把翅膀抬上去 ？OK， 鸡的样子，这个鸡，大家吃鸡腿比较多了，那鸡胸肉也有吃啊。OK， 鸡的胸很多肉，那鸡的背有肉吗 ？OK， 一点点的，你自己看一下，你如果胸肌啊有这个也是啊，你这个合起来的力道比你打开的力还大。Okay, in the case for wing driver, okay, this is a pectoral muscle. When they are contracting, they are pulling the arm down. So this is almost a level down. Okay, but remember, bird or chicken has not much muscle on their back. They have a lot of muscle in their breast. Okay. But how do bird or chicken raise the wing up if there were no muscle, okay, at the back or little muscle at the back? So you can find that the muscle that was raised, that was used to raise the wing, are located pretty close to the pectoralis muscle, okay? And this pectoral muscle, this supracoidal muscle, are using a pulley system. 如果你把这个鸡胸肉，然后还有这个上胸肌放在一起看，它都连到了鸡胸的龙骨 ，OK？ 它这个肌肉啊，这个上胸肌要把翅膀抬起来，但它位置却跟鸡胸肉在一起。如果照你一样的连接的话，这个翅膀是没办法抬起来的。结果你会发现，这个上胸肌，它基本上是它的肌腱跨过了你的肩膀 ，OK， 肩胛骨，然后这个肌腱绕过肩胛骨，然后连接到你的上手臂的骨头，所以这个肌腱，上胸肌的肌腱跟你的上手臂，其实就变成了一个这个滑轮系统。我们来看一下一个简单的影片。
Specialized muscles to move those wings, so your pectoral muscles in particular are going to be very large.
Hundreds of muscles, tendons, and ligaments power a diverse range of wing movements. The centerpieces of this system are the flight muscles. Pectoralis major, and beneath it, supracoracoideus. Together, they form the engines of avian flight. contract, they pull the humerus bone in each wing down, creating thrust and lift. In immediate response, the supracoracoideus, connected by a tendon to the top of the humerus, works like a pulley to lift the wing every time the muscle contracts.
This is another terrific design because this pulley system eliminates the need for a large, heavy muscle above the shoulder to lift the wing back up. Instead, the flight muscles are all below the wings, where they help create a compact center of gravity that really stabilizes the bird's body in the air.
我讲完这个例子，然后我们来具体看一下这个结合上更多的这个例子。So in this case, so we are solving problem step by step. First is to write the position coordinate from the fixed data. And then second, identify the variable length, and then leave out the constant length. And then finally, do the time differentiations, you are able to get the velocity of the point of concern. Okay, so I'll take the example here. So in this case, you have one mover pulley and one fixed pulley and 3 sections of the rod. Okay, how are you going to describe this motion? 我们大概很快速的这个解一下这题。你现在这个有一个滑轮，然后有一个滑块 A， 然后这个绳子再连到另外一个动滑轮，然后再拉上去，然后动滑轮下面这里有一个物体，这个叫 B。So in this case, you have the view point A, B. So in this case, you can see that from the fixed pulley to the point A, you can write this is X. From the ceiling down to the movable pulley, you can write this is Y. They could have a radius R1 for both fixed, R2 for the fixed pulley, R1 for the movable pulley. Okay? So if you want to relate the position X and Y, yeah, you are adding the sum of the length. Okay? So what is the length of the cable? This, and this. Okay? So here, you might see X. Okay? The sum of the length, total length is X. This part I'm not sure. But you know that the ceiling position and the height is fixed. So then this is going to be Y minus plus Y minus a fixed height. Okay? Okay, this is head. And then next, you do add this section of the cable, then you have Y. Of course, if you like to be precise, you can have the R2 certain angle to describe the arc length, and then this is plus R1 180 degrees. Okay? Only a few terms are variable with time. This is the Y. Okay? So to be simplified, you can write X plus 2Y. Okay, minus a constant plus other constant. Okay, and equal to the fixed length. If you do time derivative, this is going to be 0. But what is not 0 is the x dt plus 2 times dy dt. All other terms are 0. So in this way, you can say, oh, my VA plus 2 times the VB, okay, is equal to 0. Okay, so this is how to solve for the example here. 这都没看到没有？所以我们在解题的过程中， 基本上就是算线的长度。OK， 线长基本上是 x 加上这个一个定滑轮的一个假设是90度的弧长，然后再加上2倍的这个动滑。OK， 好，不管你的这个 y 的参照点在哪里写，刚才老师写法是 y 的参照点是天花板。OK， 这里的参照点它是用定滑轮的高度，那无所谓，反正你写出来的这个式子，它对时间微分的结果是一样的。So in this case, when you do time differentiation, all other fixed height or arc length are all going to remain constant and not change with time. So in the end, you have the expressions, horizontal position and velocity, and vertical, 2 times the vertical velocity add up to become 0. And if you do one more times of time differentiations, 1 times the horizontal acceleration plus 2 times the vertical acceleration of 2 different blocks, they add up to be 0. Okay. 所以根据这个缆绳的固定长度，你就可以找到缆绳上不同点 ，OK， 它不见得是2端，它现在可能是一端在末端，另外一端在动滑轮上 ，OK， 所以这个时候，你就可以把关系找出来 ，OK。In this case, you could happen to have a more complex motion. Okay, in this example, then you're going to have 2 fixed pulley and 2 movable pulley. So before doing the solutions, you got to define the coordinate so that you can find the relative motion. 好，我们再看一下。Okay, in this case, let's draw the common ceiling, 2 separate fixed pulley. Okay, then you have block A on the right side, and block B on the left side. Okay. And in between them, you first have a movable pulley, and then next connect to another pulley, another movable pulley. Then this is the one. Okay. 在这个过程中，同学要注意的是什么？你有几条绳索 ？OK。然后那个绳索的位置，我们看一下，这个pulley是 D， 这个pulley是 C。OK。然后这个时候，你的这个绳索，这个是，你可以说这是第2条。OK。还是另外一个呢？哦，另外一个是第1条是这个。当你有两条绳索的时候 ，OK， 我们可以写一个 Cable 1 is the blue color one. Okay, cable 1. Okay, must be a constant. And the next cable 2 is another constant. Okay, you can say C2. Okay, but how do you add up them? Then you are concerned about the motion of YB, motion of YA, and then we're also concerned about motion from the ceiling down to YC. Okay? So let's have a look of the rod length point by point. Okay? And then you got another one which is the pulley location YD. Okay? Okay, let's consider the motion one by one. Okay, 我们就先来看这个黄色这条线吧。这 YB 这个假设这个 B 点 ，OK， 固定长度它不变，所以这个 YB 是一个定值的哦。然后黄色这条线，当然你要加可以，你就加弧线 ，OK， 这个有一个半径乘上一个角度 ，OK 可以。然后再来这个 C 点这条线呢？ C 点这条线是这一段 ，OK， 那就是你的 YC，OK， 啊，你可以再加上它的这个误差，假设是另外一个角度，然后后面再加上这一段，啊，这一段怎么找？看到没有？你有 YC。 你有 YD， 所以这段的这个距离就是 YC 减到 YD。Okay. So in this case, if you are doing time differentiations, then you are left with VB plus 0 plus VC plus 0 plus VC minus VB. So that is your equation for cable 2. Then next, how about the equation for cable 1? Okay. The equation of cable 1 is first is the YD. Okay, you will possibly have another pulley 3 arc length. And then next, what is this segment? This segment is basically a constant minus YD. Okay, then you can say D the constant. Okay, so it's not just there. One piece here. Okay, then you have a rock. And then you have this length again. Okay? And then by doing the time differentiation, okay, then it is possible to obtain what? 0 equal to how many YD? 1 YD, 2 YD, 3 YD. Okay? Oh, not YD, this is YA, sorry. Okay? This is YD. Okay, this is Y. The final part is not YD, the final part is YA. Then eventually what you have? You have 2 YD, 2 VD, plus 1 VA. Okay? So in this way, you are able to write your equation. So 这个部分就有点像算账一样，你要一笔一笔算 ，OK？ 所以当年没有计算机，其实节省 ，OK 也是一段一段，一个节一个节，但是我们现在是算的是长度，是节数。Okay, in this case, so you are able to write the equation for the first line. Okay, first line is connecting. Okay, you can see if you are drawing the first line. Yeah. Connecting this way. Okay. And then for the second line, second line. Okay, first this is a second line, then you have this another one. Okay, yeah. So this is how you get your equation. Okay. 好，那我们这个部分就说到这里。好，我们接着继续上下一个课题。我们看一下有那个有其他那个简单的例题。OK， 这些就比较复杂，题目就比较复杂。但是不管怎么复杂，你毕竟还是用几何问题啊，就把这个线的长度就是算出来。OK， 所以在这个场景搬家具是用窗口进的，你觉得是在哪里有出现？在台湾有这么搬家具进门的吗？是哪一个天才建筑师搞到家具要从天台进来 ？OK， 你们猜猜看，如果要去旅游，哪里会看到这种场景？啊？搬钢琴，可能。钢琴为什么不能转一下？钢琴转个角度。OK， 这个场景在2个大城市常常看到。你如果出国旅行 ，OK， 这2个大城市，它开创者都是同一批人。你猜猜看，哪2个大城市看得到这种，就是搬家具、搬沙发，它要从天台进，或者从哪进 ？OK， 这种场景你可以在荷兰、阿姆斯特丹，还有纽约 ，OK。你现在只记得的这个纽约啊，它不是英国人开辟的 ，OK， 它是荷兰人开辟的，当年叫 New Harlem，OK， 这个哈林区 ，OK， 所以为什么这个荷兰人这么作死啊？搬家具不能从里面，一定要从外面 ，OK。你如果去阿姆斯特丹看一下人家的屋子，我们看一下，看一下这个阿姆斯特丹。我们来看一下阿姆斯特丹的这个街景。太小，大一点。OK。好，这就是阿姆斯特丹的这个街景。这个的话 ，OK， 你觉得哪一家比较有钱？很多栋楼，哪一家比较有钱？来，我们开始办。 我们要搬东西啊 ，OK， 但是搬东西之前要看大门1、2、3、4、5、6、7、8。OK， 不要讲有钱，我们换一个角度，哪一家还的门牌税最便宜？台湾这边叫房产税。OK， 在荷兰或者英国英语系国家叫做门牌税。啊，你觉得哪一家还的门牌税最贵？OK， 这家是最便宜，没有门，不用还。那这一家门比较小，门牌税比较低。所以当年荷兰阿姆斯特丹，它的这个市政府抽税的标准就是你门的大小决定你还的门牌税 ，OK 或房产税。所以也就是有这样的情况底下，我要还门牌税还少一点，啊我门弄窄一点，到时候你要搬家具的时候怎么办？啊就只能用这个花轮组把它吊上去，所以这个是一个背景故事。OK， 然后还有，你去阿姆斯特丹，很多教徒嘛，分2种，一个叫基督教，就是新教，另外一个是天主教。你看看，哪一家是基督教？新教，哪一家是天主教？以后你们去旅行，你可以长一点这个知识。来，1、2、3、4、5、6、7、8。OK， 所以新教或者基督教是在，你可以说是从欧洲或者新欧洲发展出来的。旧欧洲就是罗马 ，OK， 所以罗马这个只要，罗马就是天主教，它只要对于就是怎么说？一般来讲就是说窗帘都拉紧的叫天主教。清教徒你24小时都要这个很虔诚，什么时候都要给大家看到你非常虔诚。所以这个窗口全开没窗帘，那就是新教徒。对，这是一个小故事。So in this case, then you can see that, okay, there might be a need of lifting up the sofa or any big piece. You use the pulley to pull it up, and then you enter the house by the balcony, where you have a bigger window. In this special, due to the religion and historical reason, so the Dutch people in Amsterdam, they will have a small door to reduce their property tax. Okay, but they still want to have a big balcony and big window. Okay, so they can enter this. 这个是我们刚才已经解过的题。OK， 这题也差不多。OK， 好，那我们今天这个部分，华文的部分就大致教完，然后你们回去要练习的话，有一些额外力量可以自己去记。So the next topic we are going to cover is about the relative motion. We've learned about 2 objects connected by single constraint, or multiple objects connected by multiple constraint. Okay? But now, if there are no constraint, okay, you might also have 2 objects moving relative to one another. Okay? So take for example, you might be on the platform of a train station, and you might have observed a passenger on the train is moving, while the train also moving. Okay? So the ground viewer, the ground-based observer on the platform will see that train is moving at speed 9 meters per second. But the passenger himself move relatively to the train by 2 meters per second. So to the observer on the platform, what is the total speed the passenger is moving? So indeed, it is the sum of the train speed plus the relative speed between the passenger and the train. That is 9 plus 2. 所以这个时候我们这个相对运动，这个时候是谁相对谁？我们这边看到的是乘客相对火车的相对运动速度是向右2米每秒，然后火车本身向右的移动速度是9米每秒，所以在绝对观察者的这个观察底下，这个乘客的绝对速度就是2加9就是11米每秒。Okay? So this might look very simple. This is a collinear motion that you can easily differentiate what is the absolute velocity from the platform observer and what is the relative velocity of the passenger to the train. Okay, and then next, what else can you see? Okay, 还有这个相对运动的这个例题就是，这几天都下雨 ，OK， 你撑着一把伞，所以雨珠，如果说没有风吹，这雨珠就从空中垂直落体掉下来 ，OK， 然后在掉落的过程中 ，OK， 你撑着这把伞 ，OK， 那就顶住了这个雨珠 ，OK， 但是当你开始要往前运动的时候，你就发现，这垂直落下的雨珠，怎么是迎着你的面打过来 ？OK， 你不动的时候，雨珠是垂直落下，你开始往前走的时候，这个雨珠就迎着你的面打来，所以这个时候，这个雨点相对你人的这个速度是什么呢？你人的速度如果是0不动，它这个雨珠就是垂直落体。So in the case when rain is coming down, then there is a rain drop speed that is vertically downward. 好，我们来看一下，就是雨下来的这个速度，这叫 dr，OK。那你人的话，你站住在这里，这边看，它就是垂直下来的，对不对？So in the case that when you are observing a free falling raindrop, so this is not the free fall, okay? This is not the waterfall. 这不是瀑布，这是雨点掉下来的速度。What happens if you start moving? If you start moving at the horizontal speed, okay, vm, what would you perceive the speed of the rain? So in this case, you are writing the speed of the rain relative to the man. Okay? So this is going to be a vector difference. The absolute speed, absolute velocity of the rain minus the man velocity. Okay? 所以这也没有太复杂。所以你要怎么画呢？雨还是垂直的下 ，OK？ 但是你的人的它相对人的速度，当你讲相对的话，那就是相对，就反过来了，就 this Vm